Good afternoon, everyone. Welcome back to the course Natural Language Processing. And today we will learn on Chapter 9 about the Introduction to Name Entity Recognition, or in short, we call it NER. And this is the outline of today's lectures. We will have what is NER and what we can do with NER. And we will see what are those challenges to perform NER in NLP. And lastly, we will see on the tool as well as library and implementation to perform an ER task. So now let's start with the first point. What is NER? Before we come into NER, we should understand the name entity, or in short, we call it NE. What is NE? NEs are definite noun phrases that refer to specific type of individuals such as organization, persons, dates, locations, geolocation, so on and so on. And these name entities are normally exist in the piece of text which we can be extracted from those information. And this table shows the commonly used types of NE which are already predefined in the text. We have these types, they are commonly used. We have organization, referring to some specific information representing the organization. And we have the person, which represent the names of the persons that are written inside the text. And we have some other types. And we notice that for the GPE here, it is referring to the geopolitical entities such as city, states, and country. So after we know what is an NE, and next, we will try to understand what is NER. NER is the first step towards information extraction that classify name entities, or we have given a short NE, in text into the predefined categories such as person names, organization, location types, and some other types of NE. So we notice that NER here, they are used in the information extractions. Be given us a text and we should be able to extract some information, and next we can describe what this text is about. And the goal of NER system is to identify all textual mentions of name entities, and it is divided into subsequent tasks. The first one is called identifying the boundaries of the NE. We want to know what is the scope of NE in this context, what it actually means. And the second point is to identify its types, whether it is about the person, location, times, event, or product. Okay, next we will see what we can do with NER. NER is used in many fields in natural language processing, and it can help answering many real-world questions. For example, if we want to find out that in the articles, we want to see what are the companies that are mentioned in the news. For example, they are giving some useful products, or the products are popular in the market. So we can extract those information from thousands of records using NER. The next example is we can retrieve the information whether the products specified mentioned in the complaints or review or not. For example, the company may have the feedbacks from the customer, and they want to know whether the product is reviewed in a better form or negative form. So there are many reviews from the user, right? So if we take a manually reading those information, it may consume a lot of time. So if we have an NER system, it can help to facilitate these works and save us many time. Next, does the tweet contain the name of a person? And does the tweet contain this person location? So this is to detect the name of person as well as their location address, whether who they are and where they are at that moment. So these are really useful information in case that we want to find out something from a particular place or particular person. So a name entity recognizer can be built with some set of libraries. We have NLTK, or we can use SPACY, or we can use TensorFlow, which we have learned in the previous chapter, in order to identify this information, giving us a text to identify the name entity. We can use NLTK, SPACY, or TensorFlow. So next we will see some few use cases that are used in the NER systems. The first one is classifying content for new providers. NER can scan the entire articles and reveal which are the major people, organizations, and places discussed in them. So we have many texts in the articles, right? We can spend some time to read all those documents and find out what are the people, organization, and place. But in such a case that we have an NER system, it can help us and save time to read through those documents. So we just pass the input as text, and then we get the result, whether it's about who, which organization, and where is the location. So from here, knowing the relevant text for each article, it helps in automatically categorizing the articles in defined hierarchy and enable smooth content discovery. So when we say smooth content discovery here, it gives us a very fast way to find the content from the given text. So this is an example of an existing tool. We give some set of information, and here are the outputs from the NER systems, which recognize the names and some other information from this given sentence. And next we will see on the customer support. Suppose that we are designing an internal search algorithm for an online publisher that has millions of articles. So our goal is to search, and if for every query, the algorithm needs to end up searching all the words in those millions of articles, because we have many words. So this process will take a lot of time, and in such a case, in some case, we may miss some information from the article as well. So instead, if NER can be run only once time, all the article and the relevant entity associated with each of those articles are stored separately, this could speed up the search process. So what does it mean here? We do an NER system once time. It will extract those name entities into the storage. It's stored separately. And next, when we want to search something, we can just only check that keyword with that separated storage name entity. So this will enhance the searching process as well. So with this approach, a search term will be matched with only the small list of entities discussed in each article, leading to faster search execution. So it is really helpful in case that we want to search some specific terms in thousands or millions of articles. It is an efficient search algorithm. Suppose that we are handling the customer support department of an electronic store with multiple branches worldwide. And then you go through a number of mentions in your customer feedbacks. So we have many feedbacks, so we need to go to each of them. Instead, if you pass it through the NER API, which allows us to perform NER operation, it will pull out the entities, location, and product here. So this can be used to categorize the complaints and assign it to the relevant department within the organization that should be handling this. So we know about the feedback from the customer about a particular product, and this product was sold on which location, for example. So we can figure out and try to solve the problem immediately by contact to the corresponding department. So next step, we will see on the challenges in NLP. What are they? Before we can perform NER operation, we face some major problems which should be concerns during our preparation process. So the first challenge is called name entity terms. They are ambiguous. So ambiguous here, what does it means? For example, we have the word may and not. They are likely to be parts of any for date and location, but at the same time they could be part of a person name, right? So these are said to be ambiguous because at the same time it can be used as the name of person, or it can use as dates or location. And the second challenge is called multi-word names. For given a word, it can be composed of many words. For example, we have the proper nouns, compound noun, it is called compound noun. We have many nouns of that word, right, to compose that particular compound noun. And on the number third challenge is the names that contain other names. So in case that we have a very long name, the system for performing any or may be difficult to identify those name entities. So next step, we will see on the tools, library, and implementation used to perform in NER. So what are libraries that we can use? We can have Stanford NER, or we use Spatie, NLTK, or TensorFlow. In case that we want to use Spatie, we need to install those set of libraries using this command, pipe install Spatie. So from Spatie, it provides datasets, but we need to separately download it after we install Spatie. So to do this, we type under command to download the dataset in English. And in case that we want to use an NLTK, we should firstly install those libraries first. And here's the tools and touches that are used in NER. They are existing tools that we can use. We have Nerds, Threads, Fox, Zementa, so on and so forth in this example. And for the touches, we have Stanford toucher and LBJ toucher, and we have BBN identifier. And this picture gives you an example on the tool called Zementa extractors, which allow us to perform NER online. It is a web-based application. So how we can perform NER using NLTKs? From an NLTK, it provides an function called NE-chunk, which chunk the name entities into trees, which then can be extracted to obtain the particular terms. In NLTK, it provides a classifier. It has already been trained to recognize name entities. We call it NE-chunk. So this function accepts several parameters. If we set parameter binary equal to true, then name entity are just touched as any. As you can see in this example, we put binary equal to true, and then the touch from this chunk is recognized as any. It does not give us the types of any. But in case that the classifier, in case that we don't set any value for binary here, the classifier will add the category labels corresponding to its types. For example, person, organization, GP, times, and that. As you can see in this example, when we chunk this sentence, so it gives us the particular types representing in this input sentence. So we have JPE and we have persons here. So to be able to use the any chunks, we should provide a particular sentence. So this sentence in this example, we obtain it from a corpus tree bank using this command. Anyway, you can use some other draw sentence as well. And next we will see on how we can perform NER using the Spatie library. So make sure that you already install Spatie. So giving us a piece of text storing in an article variable, and we import the library. So next, to be able to perform NER, we need to call to load function first, and next we will call to spaCy NLP. So from spaCy NLP here, we pass the articles to the loaded model. So what is the result obtaining from these codes? So when we print the original sentence, so these are what we already written in our variables, and the output from performing any OR, we got these informations, which representing the types as well as the value for each any. So we notice that we should install spaCy as well as the datasets so that we can load up our models in order to perform any OR on a given text. In case that the text is given in French language, we should download the dataset in French as well. Okay, so now we come to the end of this lecture, and I hope you have learned several features as well as the libraries that can be used to perform any OR test. And next, let's have a homework on the name entity extraction from a text. So give a sentence from here. What we want from this exercise is to extract these informations which representing the name entity existing in this given text. So from this you can use spaCy or you can use NLTK depending on your favorite library. Okay, thank you for participating in the lecture today. Hope to see you in the next lecture very soon. In addition to this homework, please visit these hints which give you some more insight of the implementation for doing this homework. Okay, goodbye.